Hi, this is the first time we're going to try video classes since I can't be there today. And some people have expressed some frustration over the web video classes. So you are going to need your books out. If you don't have your books out, pause this, get your book, and open up to Chapter 7, Lesson 2. This class is about inverses of relations, inverses of functions. An inverse is something that undoes, just like multiplication undoes division and subtraction undoes addition. Inverse functions undo. So remember that x values are input values and y values are output values. If you have an inverse function, then you can reverse those. The output value becomes the input value. If you look at page 499, there's an example of that at the top. It shows the input of a function is 3 and the output is 9. If you took an inverse of that function, the input would be 9 and the output would be 3. I want you to take a minute and look at that, and we'll go back to this in a second. I should have started a second ago by welcoming you to my home. You can see the kitchen right behind me. Alright, look at example 2. On example 2, it shows you inverse functions. The first one, it shows f of x is equal to 2x. That's multiplication. The inverse function would be f to the power of -1, which means inverse function of x equals x divided by 2, because the inverse of multiplication is division. The easiest way to write the inverse function of a function is to take the original function, y equals 2x, reverse the x and y, which would be x equals 2y, and then solve for y. Look at that, think about that. If you took that first function on example 2, f of x equals 2x, and you reminded yourself that f of x is the same as y, then that function reads y equals 2x. If you replaced the y with x, you swap them, and the x becomes y, the y becomes x, then you have x equals 2y. Then if you solve for y, in order to solve for y, you would divide both sides by 2, and you would have y equals x over 2, which is exactly what the inverse function is. I want you to look now, pause the video, and try to do this following one. F of x equals x over 3. Write it down. F of x equals x over 3. Pause the video, and when you come back, be prepared to tell me what the inverse function is. Alright, how did that go? Hopefully you reversed, or you replaced the f of x with y, then you switched the x and the y values, which gave you x equals y over 3. In order to solve for y, you would multiply both sides of the equation by 3, and you would end up with y equals 3x. In order to write your answer, you need to write it in function notation, if you didn't already. So it should be f to the power of -1 of x equals 3 times x. If you didn't get that, or somebody doesn't understand, you need to pause the video and figure out what's going on before you keep going. The next one we're going to look at is example 3, still on page 499. This is a multi-step function. You do it the same exact way. You take the original function, f of x equals x over 4 minus 5, switch the x and y values, and solve for y. I want you to do your own, and I'm going to give you one that doesn't have the answer in your book. You can pause the video and walk through the example in your book if you need to, or you can go on and do this one on your own. Here's the one that you can do on your own. F of x equals 5x minus 7. Write that down. F of x equals 5x minus 7. Do that one on your own, and we'll walk through the solution in a moment. Go ahead and pause the video. Alright, hopefully that's going well for you. If you take the function f of x equals 5x minus 7 and switch the variables, you end up with x equals 5y minus 7. Now it's time for your Algebra 1 skills. You always add the 7 to both sides first. Then, because the 5 is multiplied against the x, you divide both sides by 5. You should have ended up with y equals x plus 7 over 5. Then in function notation it would be written f to the power of negative 1 of x equals x plus 7 over 5. Hopefully that wasn't a problem. If it was, help out anybody that needs it. You can also look at the videos on the textbook website as well. There's one last thing I want you to notice, and I'm going to look at example 1 and example 4. Notice that they have graphed there in blue and red the original function and the inverse function. If you were to hold a mirror across the dotted or dashed line, notice that the red and blue functions are inverted across that dashed line. In both of the cases, in both graphs, if you were to graph the original and the inverse, those two graphs would be mirror images or translated across that dashed line, and that dashed line is at y equals x. Okay, it's the diagonal line. It goes through the origin, and it's the center point where the inverse and the graph reflect. Okay, hopefully that makes sense. It explains it for you a little bit at the beginning of the lesson on page 498. It's one way for you to know if your graphs are accurate, if you can see that they cross over that dashed line at y equals x. Okay? Good luck with this lesson. Watch the videos online. Do your work carefully. Save your work. Have questions ready for class, and I'll answer any questions that you have. Have a great day.